All right, we are live now. So we'll give everyone a few minutes to join. Okay, if you're just joining, we're going to start in just about 30 seconds. Okay, hello everyone and welcome to today's webinar. I'm Alyssa Arroyo and I would like to introduce you to our presenters for today, Tally Einhorn and Hod Rotem from K2View, who bring a combined experience of over 15 years serving enterprises in data-intensive operational and analytical workloads. Today's session, How to Use Data Masking to Protect Sensitive Data in Your DevOps Pipelines, is being recorded and will be made available on the BrightTalk platform after the webinar ends. As part of our session, we will present several poll questions to which we would love for you to respond. We will share the anonymized statistical results of the polls with our audience. Finally, we will have a Q&A session at the end. So please, at any time, jot down your questions in the questions box, and we will try to attend to as many of these as time allows. We promise to answer all remaining questions via email following the webinar. With that, let's get started.
Okay.
Hallie, if you can.
Yes, I just did.
Thank you. For those of you that are not familiar with K2View, we offer an operational data fabric. Our data fabric enables Fortune 2000 enterprises worldwide to deliver a real-time, trusted view of any business entity through what we call data products to any consuming application. We've been in the data management space for over 10 years, and we are very proud to partner with some of the biggest companies and consulting firms in the world. So with this short background of K2View, I would like to turn it over to you, Tally.
Thank you. Okay, so today's session, we will focus on data masking. First, I will start describing the data masking use cases and challenges, and then data masking business driver. What are the main business motivations for data masking? What are the critical main capabilities that need to exist in data masking tools and solutions? And then I will describe our solution, K2View solution, the masking data by business entity based. And then I will hand over to Hod, which will present unstructured data masking demo. So let's start. Okay, so first of all, to be on the same page, what is a data masking? Data masking is one of the activities, one of the methods of data privacy, derived from data privacy to protect private data. This is a process which replaces a sensitive data that can identify a person, like a credit card or name or SSN, with a fake data The sensitive data is masked to be protected against the confidentiality or privacy abuse by the user. Actually, the most common use cases of data masking that is required is when we copy a sensitive data in non-production environments. For example, if we have a production system which contains the list of entities, a list of customers with the real names, the real SSNs and age, we need to have a real data and a real usable data in the testing and development environment. Yet we don't want to copy this identifiable data, this private data, into the testing environment. It means that even if we copy Brown and Duncan customers, Brown becomes Michelle's, Duncan becomes Lee. We also change the value of the SSN and the age. So this way, the testers or the administrators or the developers can still use and run some application processes on these customers, copied customers, but these copied customers cannot be identified as individuals anymore. Okay. Now, what are the main challenges of data masking? So we all agree what is data masking, and this is important in order to protect a private data. But it still involves many challenges. First of all, we need to identify what is a sensitive data that need to require protection. So name or SSN, this is quite straightforward, but there are many data sources that may be involved, many data types, data objects. We need to identify them. The type of the data that need to be protected also depends on the regulations in each area and in each country. So this is the first part, the first challenge, to identify what data needs to be protected. The second one is maintaining the ability to carry out the business processes with the masked values. So even if Brown becomes Michelle or Duncan becomes Joe, we still need to use them for the functional needs. For example, in testing environments, run the system. So we need to verify that the masked values actually are aligned with the business and the application rules. For example, preserve the format of the masked data in order to make the data usable in the target system, the masked data. The third one is identify and mask both the structured and unstructured data. Hod will show later today a demo how to handle unstructured data, growing amount of unstructured data like PDF files or JSON or XMLs, semi-structure. And all these goals and challenges still need to be achieved by minimizing the time and the cost of the data masking, because we want to avoid extensive, custom, and expensive developments. Okay, so what are the main top business drivers for data masking? So first of all, this is the expansion and maturation of privacy laws globally around the world. This is a global trend. Many regulations that set to protect private data, like PCI, GDPR, CPRA, CCPA. Also insider threats, including users of non-production data sources like programmers or testers or DBAs or administrators, and users with access to insufficiently protected environments. So the basic idea is that unauthorized users must not see and be exposed to a private data. Also, growth of machine learning or artificial intelligence or BI project and migration of these projects to the cloud. Data privacy and security is viewed as a primary barrier to artificial intelligence implementations, according to the recent Gartner survey. And also remote working mode, actually it's emerging the attention to the security issues. This remote working, of course, is accelerated by the COVID-19 situation. Now I would like to describe to you the main data masking use cases. So the first use case that I would like to talk about is actually a static data masking. static data masking is when the data is masked at the source. Its source before it's used, the data is masked in advance, and then the data is consumed as a masked data from the data source, which has the masked information. The masked data set is later used by the data consumer. So the data consumers are not exposed to the real data. A classic example for it is actually the TDM, test data management, which can copy data from one environment to another environment. This tool can extract the data from the source, mask the sensitive data, and then store the masked data in one or more target testing environment. And of course, there are some variations that depends on the business use case. In some cases, you need to be John to become Danny in all target systems. In other use cases, you want Joe to become Danny in one environment, but you become Richard in another environment. And even in the same environment, if you would like to create some replicas of John, you would like in this case to give each replica a different set of masked values. So the data is stored and masked in the target testing environments and then can be consumed by the related user. The second data masking use case is dynamic data masking. The dynamic data masking actually applies the masking operation in a real time. It means that the data does not change in the data source repository, but it is changed when consuming the data. When authorized user can access the real data because they are authorized and they have the right entitlements for it, but unauthorized users that need to consume the data are provided with masked data instead. This is a second use case. The third use case is a data masking use case. It's an unstructured, semi-structured, or a reduction. So masking data in unstructured files such as PDF or Excel files or text files, log file, audio, etc. And also masking data in semi-structured files such as XML and JSON. So this type replaces the data with chosen reduction characters such as X or blackouts, parts of the data. You will show HOD will show a demo of masking unstructured data. Okay, before we continue, I just want to go over some basic terminology, data masking glossary, so to verify that we are all on the same page, and talk about several main terms that are related to this world of data privacy and data masking. So the first one is anonymization. Actually, this is a pair, anonymization and pseudo-anonymization. Anonymization is when we remove some personal identifiers, direct or indirect, that can identify a person, an individual, like name, address, phone number, etc. And traditionally, this is referred to as a non-reversible data masking. This is a non-reversible process. On the other hand, pseudonymization traditionally refers to the reversible data process, data masking, tokenization, or encryption, when on one hand, the personal information is still kept, it's still kept and cannot be viewed and seen by unauthorized users, but in some cases where there is a need, this is reversible and the real data can be shown to authorized users. Tokenization is replacing sensitive data with generated token. This is a reversible process and based on the entitlements. And format preserving, if you remember, I just talked about the need to preserve, to be aligned with the business logic of the applications, because we need the application to run properly with the mask data. So the new value, this is preserving the new value with the same format as original value. It does not have the same value as original, but it has the same format. And this can refer to data encryption method. It is called FPE or tokenization or even masking. Okay, so now we understand what is the data masking, what are the main use cases for data masking, and what are the challenges of data masking, main challenges. In order to address these challenges and perform the data masking properly, the data masking tools and solution must need to have the following capabilities, group of capabilities actually. So the first capability that I'm going to talk about is the data and relationship discovery. The second group of capabilities is the data masking rule management, how to set the data masking rules and how to deploy them, data masking operations and management, and then reporting for compliance. So what is the data and relationship discovery? The same sensitive data types may be present in multiple objects of the same data sources, as well in other data sources. For example, a credit card number can be resides even in the same application in different tables, having different column names or different data sources that are not tables, with different names. So we need to identify where the data, the sensitive data is kept, and what are the relations between the different data objects. This is critical for maintaining the referential integrity of the data source for the application that use the masked data. Again, if I change Joe to Danny, I need to change Joe to Danny in all relevant places. Typically, this achieved by using combination of several methods, a data repository schema that can provide relationship as well as tables and columns of interest based on, this is based on the metadata, the relations in the structures of the table. It can be also achieved by checking the actual data in the repository, checks for data patterns, for example, and data relations. And it can also be checked, checking transaction logs or application code and real-time monitoring of application execution. This can provide some additional insights into the relationship that defined at the application level. The next capability, the next group of capability is data masking rule management. So after we identify what data needs to mask and we have the mapping between the different data object that needs to mask, we need to apply the correct masking rules. So the masking rules needs to be applied, that needs to be defined in one centralized configuration tool. This enables using this rule across multiple data sources. If I would like to have a logic to mask SSN and I have the SSN in different applications, so I need to apply the same logic, the same masking rule. This also enables consistency of masking, again, as well saving the time and effort because we can have a reuse of the same masking rule, same masking logic in different places. And it also helps to ensure referential integrity of the data. Pre-built data masking algorithms to address specific data types of replication, to have some templates or pre-built algorithm that can be used like masking a zip code, masking SSN, masking name, componentization of these algorithms to enable a reuse of the same masking rule in different places and different processes. Mask data from a variety of technologies ranging from legacy mainframes to modern cloud-based systems, and also the ability to apply data reduction rules for structures as well as unstructured and semi-structured data, PDF, Word documents, XML, JSON, etc. The tools to manage data masking operations management, this group refers to the tools to manage the full life cycle of the masking data, to deploy the masking rule that were predefined, schedule or trigger the masking job, monitor the execution, schedule and manage masking job via APIs or services that can be called by services of external systems such as test data management or tools or CI/CD pipelines, and also validating the result, validate that the sensitive data was actually successfully being masked. And the last group of capabilities are reporting for compliance. The data masking tool should be able to report for sensitive metadata, what kind of data objects and the columns that have been masked, data dependencies and relationships between them, and what masking rules have been applied on each type of data. Now, I would like to talk, after describing in general the masking trends and the masking capabilities, I would like to talk about K2View masking solution and the advantages, of course, of the K2View masking solution. So masking by business entity. Before we dive in, just few words about the concept of microdatabase and business entity of K2View. So basically, a business entity can be a customer or patient or person, but this is a business-driven definition, while in actually the customer might be in many different cases, the customer might be divided between different data sources. So it may have one source for interactions, another one for campaigns, CRM, invoice and payment. So if I have a customer called Janet Rivas, the data of Janet Rivas is divided between different places. So K2View solution, K2View fabric, actually gathers and extracts and gathers all the relevant information on each entity. So Janet Rivas, we take the relevant data from all relevant systems, and Fabric creates a separate micro database. This is actually a physical data lake on each entity, on each customer in this example. So here we see Janet Rivas. This is one customer, one micro database. And then we have another customer, John Quill. Sorry, I was too. And the third one is Tanya Rivas. So we have 3 customers in this example, and we have actually 3 different micro database. When in each time when we invoke an entity, we invoke the compressed micro database, and it's unified data. This concept of a business entity also have tremendous advantages when we're referring to data privacy, data masking. Why? The entity-based masking advantages. What are the advantages? First of all, it is flexible. We can support static and dynamic data masking in a single platform. Static, we can extract the data of each customer or each entity, each business entity, extract the data, mask the data, and keep the data masked in Fabric in advance, or even load the data into any required environment to be consumed later. And also we can support a dynamic data masking in our process, run our flow, it's called the Broadway flow, and run it in order to mask it dynamically. We can also support data masking on live system without downtime. So if there is a need, for example, to extract the data of a customer from production and then move it to another system, a testing system, we can extract the data, then process the data and mask the data, the personal data in memory, and then create the data lake, the MicroDB in a Fabric, and load it to the required environment. We can also support real-time data masking replication. It means that if a source, when the source data actually change from some reason, we can reflect this change and remask this new or updated data in the relevant target system. It also ensures a referential integrity via design, because I'm going back to the previous slide. If Tanya Rivas, if we extracted its data into one place, one logical unit from all the systems, and we define all the relations. So in this case, by design, we can keep the referential integrity of Tanya. We can verify that if Tanya becomes a Hermione, for example, Tanya will be Hermione in the interactions, in the CRM, in the billing system, etc. The same for other private attributes of Tanya. It also enables a higher parallelism and better performance. We don't work block by block. It means that we are not taking the entire customer table from production, mask it and copy it somewhere else, and then take the entire block of subscriber and copy it from one place to another. On each entity, we work in parallel, and on each entity, we actually extract all the relevant data from all of the relevant data sources and can mask them and load the masked value to the right places, to the right data sources. So it gives us a better parallelism and therefore a better performance. It is also integrated with PII discovery identifies for the sensitive data. So we can also send the information of the entity to the PI discovery as a context to make it better, to make it easier for the data discovery to discover some patterns. For example, if there is a customer which is called John Doe, so the values of John Doe can be sent to the PI discovery, and when it finds these values in some of the data sources, it can understand that this is a private data and identifies it and masks the private data. We also provide a parameter-based masking, which enable a granular masking based on environments. Previously, I described the different business cases when Joe needs to be Larry in environment 1 and Joe needs to be Jerry in another environment. So we can support this. We can support Joe that will become Larry in all environments, and we can even support Joe that will become a Larry or Jerry or George, depends on the execution in the same environment. And also we have a broad library of pre-built masking functions that can be used, like mask SSN, mask zip code, mask names. This can be used like Lego bricks in advance, and we also provide a very easy and very user-friendly customized layer to make some customized masking logic if needed. Okay, now I would like to hand over to Hod to start the demo of the data masking platform. Thank you, Hod.
Hi. Sorry to interrupt. I just want to point out to the audience that I just pushed out the first poll question. What is the #1 business driver for data masking at your company? So we would appreciate some responses. Thank you.
Okay, thank you, Talia, Lisa. I'm sharing my screen. Kindly let me know if you're not able to see this.
I see it.
We can.
Thank you. Okay, so I think we have about 15-20 minutes. I'd like to introduce you, give you a little bit of an intro into our masking capability, more specifically semi-structured and unstructured masking. Tali was talking about this unique concept called business entity that K2View uses to manage data and some of the benefit that it gives us. In our example, the business entity is a customer. More specifically, it's a customer from a financial organization. So when we look at the overall customer information, we might have some basic CRM information like first name, last name, account information, addresses. In our example, the CRM is a cloud-based application. That customer might have some financial information, billing information associated with that, invoices, payments, details of the invoices. In this case, it's coming from a mainframe, as well as all sorts of card interaction, credit card interaction. And this is a big data example. Really, the technology for K2View doesn't really matter. We know how to pick and choose all the relevant information about a specific business entity, in our case, customer, and we combine it to this micro database of this business entity. Now, our first semi-structured object that we want to mask is a simple JSON file. where you can see some basic information about myself, my first name, my last name. You can see some contact information that is a hierarchical structure, meaning it's not a one-layer hierarchical. There's some parent-child relationship under contact info. We have mobile phone, office phone, fax, and all sorts of other information here. I'll remove this, we'll use this in a bit. Data that is relevant to me. Most, if not all of this information is personal and should be masked when data is worked on. So the module in K2View that we use to manage, orchestrate, and mask data is called Broadway. And the tool that you're seeing right now, this is our designer. This is where you do the entire work and implementation, all the way from interacting with the different systems, building the logical unit, masking, loading it, pushing it, exposing, and etc. So I'm going to right-click Broadway here, and I'm going to select New Flow. And I'm going to call it Webinar Demo. Is the name. And it opens this empty designer orchestrator, and we call it Broadway after the Broadway shows in New York, because it's comprised out of stages, stage 1, stage 2, and stage 3, and etc. And in each stage, we have actors that are performing some sort of an activity. Because the first example that we're looking at is a file, I might bring an actor called file read that will read the file itself. And any actor has some properties that you need to interact with to tell it, for example, where to look for the file, and what is the pattern to search for the file. In our case, I'm just going to give it the name, person.json. And I can debug it and see that the actor produces the activity, the performance that it was meant to do. In this case, it produced this byte array object that includes the JSON information. Now, even though this is byte array, Broadway is still intelligent enough to present it in a visual way. After having taken the first actor, and I know that it's a JSON, I might bring a second actor. Let's do JSON parser. And I'll connect the two. And as expected, JSON parser will parse the JSON information that we got. Now, what's really nice about this actor and generally Broadway is that it dynamically analyzes the structure of the objects that you're working on. And it gives you a visual interaction with that structure. In our case, if you remember the original JSON, it has some hierarchical information like contact info. And Broadway is giving you this in a visual way. You don't need to develop code to understand how to look through the hierarchy and what are the elements that you want to work with. It gives you a visual representation of the object, whether it's JSON or XML or others. And now you can bring other actors that will work on the actual data. Specifically, let's say mask the first name here. I'm going to go to stage 3. I'm going to bring another actor that is responsible for masking first name. And generally speaking, when we talk about masking functionality and masking actors, we have two types of actors. We have what we call referential actors and non-referential actors. Non-referential actors will perform masking without keeping the relationship between the original value and the new one. It means that every time that I debug it, I see HOD coming in and I see a different first name, mask, fake, randomized first name being produced. In the exact same manner, every function or every masking object, and there's a long list of built-in masking actors, and naturally you can enhance and build your own and even manipulate the one that we have. But first name will also have a matching actor called reference first name that will mask the information in the exact same way, but will keep the referential integrity between the original value and the new one. So if I connect the first name here and I run it, you can see that the mask first name, the non-referential masking produced Lucia, and the reference one produced Carl. And after doing it for the first time, every time I click another debugging and another execution, you can see that the non-referential masking changes the value while the reference masking keeps the original one. And this is very important because it's likely that you want to produce the same type of referential result, not just across different files, but across different technologies and systems. I have a billing system that has first name. I have a CRM system that has first name. When I mask and load the data and manipulate the data, I want to be consistent such that the data still integrates after the data was masked. Now, similar to how we mask the first name, we would have actors for all the rest. Last name, job title, social security, credit card, all have their own equivalent actors, and actually you can build your own. What's nice about those actors is, and I'll bring an example of a phone number, is that not only they're referential, non-referential, but they also format preserving. So if I bring two phone masking object and I'll connect different lines to it, you can see that the original mobile phone had a structure that includes some non-numeric values like a plus and parentheses and spaces. And the Office phone didn't use just numbers. So the masking object will reserve or preserve the format even after it masks the data. So if here we had A223, sorry. Here the data will change, but it will keep the same format. And by the way, when we talk about masking of standard objects like social security or credit card, the masking doesn't just preserve the format, it also produces tangible, realistic information. So the masked social security will produce a real social security. It's completely randomized, it's masked, but it passes the standards of how social security should be built, what prefix are not allowed, what postfix are not allowed. Same with credit card. It will keep the prefix, meaning the type of the credit card. It will keep the length. It will even calculate the last digits, the checksum digit, in order to make sure that the credit card, the masked result, is completely valid. So in the exact same manner, I could have gone and updated all the proprietary information, but there is a much easier and a much more efficient way of doing that, and that's using our dynamic discovery masking functionality. So what I'll do here is I'll delete all these masking actors, and I'll bring another one called universal masking. And universal masking essentially includes, as part of the masking object, a discovery element. It will automatically scan the structure, in this case the JSON, and will automatically identify and discover proprietary or personal information and apply masking on it. And it uses a directory that is naturally configurable, and you can add your own rules to it as well. But in this case, we see some example of the directory or the information, how it searches and scans the data. For example, a social security number. There are different elements and different types to how we discover the data. The first one is a column base, meaning we're going to look at the name of the key in the object, in this case SSN, and we're going to run pattern recognition and pattern matching on top of that. And in this case, if it found a column or a key that has this name, it will apply this type of masking algorithm on top of it. But column is not the only type that we offer. Column is a very standard way to search based on the name. We also enable you to do it based on the data. So take the actual data that we get as an input and run pattern matching on top of it to see if it matches a certain email address format, credit card format, social security, and others. And if yes, apply this masking on top of it. On top of column and data, we also enable you to build your own discovery functions. In this case, build this function validate SSN will get the actual value. In this case, 1, 2, 3, etc. And we'll run the validation in your own code. It can be external to K2View, it can be internal. You can design and build it as part of the product. And if it passes the validation, then again, it will apply the same masking algorithm on top of it. So column, data, and data function are three options that we enable you to discover the data. There is a fourth option called data sample. it's very useful when you have a predefined set of options. For example, languages. If the product that you work with only supports 20, 100 different languages, you can provide that list of languages to us. It's a sample of languages, and then we take the data and search very efficiently to see if it matches the data sample. If it does, then apply this masking algorithm on top of it. The last thing that I would add, that this dynamic discovery uses weights system. There is a weight or score associated with each discovery, such that in this example, because the social security is weighted here 1, it will first try to find a match using the column. And if it doesn't, then it will try to find a match using the data. And if it doesn't, it will try to find a match using function. And naturally, if it found anywhere along this process, it will stop, mask the information, and continue to the next value. So in this case, all the information was automatically masked for me. And we were talking about the fact that Broadway automatically analyzes the structure of the objects that we're working with. So let's go back to our JSON, and let's add a new column here, and we'll call it ABC. And I will give it the same first name that we have here. So code appearing twice. Now, if I run the same execution, you will notice a couple of things. First, you'll notice that the structure was automatically updated. You don't need to worry about changes. Fabric automatically updates the format and the structure and gives you this drag and drop type of integration with the data without having to worry how to develop the code for it. Another thing that you can see is that the universal masking did not identify Hod as a first name, because ABC does not give any reason why this would be a first name. And the characters HOD, again, by the way, this is my name, they don't apply to a first name. And this is where the logical unit, the business entity benefit comes in. Because we have the contextual data about that customer across the different system, and we know what is that customer's first name and last name and additional information, we can use this contextual data to enrich the masking discovery. And in this case, I'm going to bring the data that I know about the customer, and I'm going to provide it as a hint to the universal masking, telling it, here's some additional information about the customer, and by doing so, it automatically identified and masked the data. So now ABC here, it's the same ABC as here, first name, the same output results. And using this universal masking applies to any format that you want to bring in. But the concept is always the same. We always look for the object that we want to mask, and we provide hints and help the discovery process by using the contextual data that we have about that business entity, in our case, the customer. So let's look at some additional example real quick. Here is a driver license example. Here, I'll run it again in real time. And some of the actors you're familiar with, I'm reading a file. In this case, it's a JPEG file. I'm loading it to the screen just so you can see visually how the image looks like. And then I'm running it through a masked image actor that, similar to what we've seen before, gets the value that we want to stream, the object, and get contextual hints in order to help him mask and identify, discover, and mask the data. Now, this image masking uses optical character recognition, OCR, in order to discover the data. But we offer different formats of interaction with images. If you're looking for a little bit more of a risk-averse option to OCR, because we have all the contextual data about the customer and we have the checks, for in this example that the customer is using, we can use the metadata for this check in order to enhance and build images. So in this case, I'm going to load an empty check, and I'm going to go to the data that I have about the customer and its checks and its metadata, and I'm going to use that information to mask and create a new image. In this case, I'm going to add a date and an amount text and a few other parameters. And now the same image would have basic information. It still doesn't have the person information and the MICR or the bank account and routing number, but this will be populated here in the next stage. And you can kind of see how the visual interaction with the data and how the actors make it very easy to work and operate on. And by using this information, I'm able to still generate images, but in a much more risk-averse process. Because OCR, when you discover the image, or when you scan it, discover the image, there is likelihood of data being missed. When you work with a blank template and fill it up with the information that you have from the business entity, you know that you will never have the information that is exposed. So we showed two examples, one driver license, another one checks. By the way, when you work with checks, there are actors that are built in for checks specifically. In this case, I'm loading a check from Home Depot, and because a check format is very standard, here is an example of an actor that will help you obfuscate or mask the information based on the regions. So this actor allows you to select if you want to mask the personal information, the payee, the dollar amount, the memo, and you can see that the person information and dollar amount is false. That means that right now I'm still going to be able to see John, and I'm still going to be able to see the dollar amount. But interacting with that is very, very simple. I can just change the format or change the configuration, run it again, and now the data will be masked.
Hi, Hod. I just want to point out we're running a little bit over time.
Okay, I'm going to run 2 more minutes. I apologize for that. Let's look at a free text example. This is me interacting with a customer representative who is trying to sell a mattress, and I'm giving him my name information, and I'm giving him my phone number and email address, credit card number, same exact context. We provide the value that we want to mask. We provide contextual hint to help with that. And after doing so, my name was masked, my phone was masked, my credit card and email all masked. And it will be the exact same thing with Word and PDF. And I'm going to run through this very quickly. I'm reading a Word file XML. I'm passing it through the masked Word, and I'm writing it back to an output called file. Here is our XML example. Some basic information, including my credit card, email, social security, even inside tabular structure, even in images that are inside the document. And as soon as I run this, it will go through the masking functionality, and it will generate a new file for me called file.docs. And this file will be masked according to the same information, even inside the table, even the image that is embedded. Similar to that PDF, in this case, I'm reading a resume file, and I'm writing it to resume.pdf. Here is the resume. Images, names, phone numbers, email address, even in different pages. This is a PDF file. And in the exact same way, I can run it here. It will create a new file called resume.pdf, where all the information was masked, including the images, including the different pages. Apologize for taking a little bit longer. Alyssa, I'm going to turn it back to you. Hopefully there are some questions for us that we can help answer. Alyssa, I think you're on mute.
I am on mute. I'm sorry about that. I have a question. Do you require a business entity data model for the masking to work?
Okay, good question. The answer is no, we do not. You can use the traditional method of masking data. Essentially, the tabular structure, the file structure, you read the file, you mask and you load. But the business entity provides a lot of added benefit. We've seen some of the advantages that Tali was talking about. I've shown how the contextual data associated with the customer can help us discover and mask data in a much more efficient way. So the answer is no, you don't have to have a business entity, but it provides a lot of benefit if you do.
Thank you, Hod. We have time for one more question, but I want to point out, I just put up the last poll question. Would you like to schedule a demo? So if you will answer that poll question, and we'll end with this one last question for Hod. How do you ensure referential integrity?
Okay, it's a good question. The short answer is that we have an encrypted vault that stores the encrypted hash salted original value together with the new mask value. So at no point do we ever actually store the original unmasked data, but we have that internal vault that gives you the relationship such that every time you get the word Elisa, and Tali mentioned you can configure it depending on the situation, we will produce the same output result. We can include, there is configuration around time to live, how long to keep this relationship. There is configuration around in which scenarios do we want to create new values. Maybe when I'm loading to the UAT environment, I want Elisa to be converted to Tali, but when I'm loading to the pre-prod environment, I want Elisa to be converted to or masked into something else. All that is pure configuration by properties of the masking elements.
Okay, thank you so much, Hod. I think that we are out of time. So if the remaining questions, we will answer via email. But thank you guys for joining us.
Thank you very much.
Bye.